Totally visible.
Yes.
Now, just a quick recapitulation. The mechanics is that subject which deals with the behavior of any object when it is under the action of some force. Then object, its properties, etc. So naturally, different classes of mechanics will be there, different categories. Those are might be solid, liquid, or gases. Solid may be perfectly non-deformable or rigid, or solid may be deformable. Then the liquid and gas normally they comes under one umbrella, that is fluid mechanics. And for solid material, if it is perfectly rigid, deformation is not possible, then it is comes under this first semester course, that is engineering mechanics. And when we include that property of deformation, so deformable solids, it that subject is called mechanics of materials, or mechanics of solids, or mechanics of deformable bodies, and popularly it is known as strength of materials. Okay, so we are here, mechanics for rigid bodies. The forces, they may be constant, they may be time varying. Now classification, either the object is at rest or in motion. We start with this object at rest, which comes under that group, statics. Okay, there we consider the simplest object, that is a particle, and two forces are acting there. And how do we get the resultant? By combining these two, and the oldest method was the geometrical or graphical solution. Okay, it's very simple. Before knowing that f1 square plus f2 square plus twice f1 f2 cosine alpha, that is equal to resultant magnitude square, and the direction of the resultant with the force f1 theta, it is represented by tan theta is equal to f2 sine alpha divided by f1 plus f2 cos alpha. That very popular, and definitely you know that and used so many times, not only for your school exam but for the competitive exam, etc. Very simple thing. And where from it comes? It comes from that primary thing, that is parallelogram. Now how people found that it will satisfy that criteria, that if f1 and f2 are two forces and represented by suitable length proportional to their magnitudes, then if we draw according to their direction and magnitude and form a parallelogram, then the diagonal passing through that point of application, it will be that resultant. Experimentally, most of the things we have done experimentally. Now can you tell me, the ये बोलता है ना, अंडा पहले या मुर्गी पहले? Now you just tell me whether the definition comes first and examples, or examples come first then definitions.
Sir, first there will be
Examples will be first.
Examples, then definition.
Examples, because we live
Examples.
we live in nature, and in nature everything is around us in the form of examples. Then we started asking question, why it happens, how it happened, in all that way. And when formally we make a subject which is recorded information, etc., then sometime we give the definition, then we go for the example, but it is combination of that. So that experimentally, first of all, we need to think very logically. Our logic must be so consistent and rigid that this can happen only in this way, and there is no other option. That type of thing we need to achieve. So whenever people started thinking in that way, definitely different experiments they perform, but not like this present day, this modern instruments, etc., very developed, not like that, just very crude method. Now you have heard about the name of Professor J.C. Bose.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes,
So,
sir.
what what did he do?
Radio.
He discovered the fifth state of matter.
Post-Einstein condensate.
And regarding trees and plants,
गाছের प्राणी
Have life.
That they have
Using
life.
the
but at that time he didn't have any. So what about the machines and instruments for his experiment? It's not like this modern day highly developed instruments. Very crude.
He used crystallograph to.
Crystallograph, sir.
So here also, I don't know. During my early teaching life, when I joined here at NIT, at that time also those laboratories were there, that engineering mechanics laboratory, but those laboratories are not now to accommodate so many subjects, so many modern departmental subjects for our development, for your rather connection with the industry, etc., etc. But those instruments are very basic and very interesting. So there was such instruments force table. So if by any chance I could access those things, I don't know whether those have been thrown out or not. So if I find, but very simple. So at point A, we just fix one pin, and there you place one ring, one metallic ring, and that metallic ring, it holds suppose two strings, very fine inextensible strings, and you apply force F1, maybe it is 300 Newton, force F2, 500 Newton, whatever it may be, you apply forces. How we apply force? Just passing the string over a pulley and hanging some weight from that hanging end of that string. So whatever weight, known weight you are fixing here at this free end of this string which is passing over this pulley, then it is pulling that ring with that force, because that self weight is acting if there is no loss in that connection between the rope and the pulley, and that full tension corresponding to this weight of 300 Newton, it is simply transmitted. It was acting vertical, now it is acting horizontal in that way. Now when that horizontal force is applied there of magnitude F1, then what happens to this ring? It is not maintaining its central symmetric position, it is shifted in this direction. Okay. Similarly, individually, if we apply a force of magnitude F2 along this direction, in that case also it will pull that ring which is placed around that pin fixed here in this way. But when we apply simultaneously both the forces F1 and F2, then what is the movement or direction of movement for this ring which is placed outside this pin? Will it move in this direction?
The resultant vector.
Along the angle bisector. Along the direction between F1 and F2?
Yes, sir.
Not necessarily to be symmetric. It will be symmetric only when F1 and F2
Yes.
are of same magnitude.
Yes, sir.
Now,
Yes, sir.
suppose on the other side of the ring, you tie one string, very fine inextensible string, and you try to pull it and try to bring that ring back to its original symmetric position, whose center will be matching or overlapping with this pin. So to bring it back to its original position, you need some particular direction for that force to be applied, and you need
Opposite direction of resultant.
Opposite of the resultant of F1 and F2.
opposite of the resultant. So before going for all these,
Opposite to the resultant.
now, which is complementary to which subject? Mathematics complementing or supplementing physics, or vice versa?
Sir, maths complementing physics.
Because physics comes first, the examples are around us in nature, and to solve that problem we required mathematics, and that mathematics started from geometry. That is the ancient mathematics. Then gradually we developed so many things. I'm not talking about computer, etc. Simple mathematics. Then it was in arithmetic, then the algebra, then trigonometry, so many things, and finally the vector, etc. So all such things. Before all these things, at least from our common sense, that we could find that you need to apply some force which should be along the direction in between F1 and F2 and whose magnitude is not equal to F1, neither F1 nor F2. So something in between. And gradually we developed that geometry to give us this thing. That the force required in the opposite direction is of this much magnitude compared to the corresponding scales of F1 and F2, and this is the direction. So experimentally we did it first. Then proper mathematics we developed and represented in some organized manner and noted all this information and knowledge to pass it on our next generation for improvement given by the future generation. So that is the development of everything, any subject, the civilization, everything. So now this is the combination of two forces, F1 and F2. Now, if by any chance there is a third force whose value is F3 and whose direction is opposite to this R and magnitude is this, then what happens? Three forces, F1, F2 and F3, and by chance F3 is equal and opposite to that diagonal of that parallelogram.
The particle will be in equilibrium.
Equilibrium.
That means there is no resultant force.
Yes, sir. Net force is 0.
And that situation is called equilibrium. When there is some resultant force, there will be some tendency of movement, and when it is in equilibrium, normally it will not move, except that special situation, resultant force is not there. The moving object continues its motion with uniform velocity, but that is in some, keep it aside for some later stage.
सर आपका ऑडियो सुनाई नहीं दे रहा है.
From right now or long back?
कुछ देर पहले से सर.
सुनाई दे रहा है सर.
सुनाई दे रहा है सर.
तो दे रहा है.
अभी भी कट के जा रहा है सर.
So might be some net related issue either from my side or from your side.
Sir, from his
So your audio.
One thing. So whenever you get that type of disturbance, please remind me. Okay. Now next thing, we did this one, two forces non-concurrent but coplanar. B and C are their point of application. So what is the way? Extend them back, draw the parallelogram, and it's not like that. The resultant will pass through this point, this point, this point of this magnitude and direction. So there is a single location that it passes through this point along this direction, along this line. Okay. Now we considered this thing. We place these forces for this Cartesian coordinate system x and y mutually perpendicular to each other and place F1, F2, etc. Then draw this parallelogram and the diagonal. This is the resultant, and find the individual angles are θ1 for force F1, θ2 for force F2, and theta is for the resultant. Then that compact formula, it comes. Definitely, you know that thing, that is F1 square plus F2 square plus twice F1 F2 multiplied by this angle content, that is θ2 minus θ1. And what about this angle made by R with this force F1, that is θ minus θ1, it is F2 sine θ2 minus θ1 divided by F1 plus F2 cosine what? θ2 minus θ1, and we get that is tangent of θ minus θ1. Anyway, there may be so many forces, there may be so many directions, different magnitudes may be there. Now, if we consider this line combined with this line, we'll get the same thing. So this line is called the free vector for this vector F2 when we are not bothered about this point of application. If it is concurrent, then determination of the resultant, its magnitude direction is the first thing. Obviously, it would pass through that point through which F1 and F2 are acting. So that is the formation of the triangle without repeating this side F2 and this side free vector F1. It could be in this way also. So that commutative law F1 plus F2 or F2 plus F1, whatever you take first, there is no problem. So whatever vector we are considering, that is the developed mathematical part corresponding to all this geometry. Then if there are three forces, then find the combination of F1 and F2. We get this thing F12. Then with F1 plus F2, we add the third force F3. So this is the triangle. We give us we get this resultant R that is equal to F1 to 3. Now, not necessarily we need to follow this type of nomenclature, etc. So this is the composition of forces. Okay. Coplanar concurrent forces, coplanar but non-concurrent forces, determination of the resultant magnitude direction and its position. Now you just tell me a simple projection from this geometry. If we drop a perpendicular from this end of F1 on x-axis, I am not going back to that preliminary things, x-axis, y-axis, etc. So those prerequisites, I hope it is very clear to you and you can remember very nicely. Then what about the projection of this F1 line on X? Projection means whenever you drop perpendicular from its two terminals, then the line joining the foot of the perpendicular.
F1 cos theta 1.
F1 cos theta 1. Now,
theta 1.
if we drop perpendicular from this terminal of F2 also, free vector F2, we get this foot of the perpendicular, and from that original foot of the perpendicular of F1 terminal, then what about this length?
R cos theta minus F1 cos theta.
F1 cos theta 1, this part. I am talking about this separate part. When this F2 is projected on x-axis, it will be F2 cos theta 2. Fine.
Sir, that is R though.
This is one end. This is another end. We drop perpendiculars.
Yes.
Sir, theta is not clear actually. First one is theta 1 and second one, sir, and third one.
For F1, angle is theta 1. For F2, angle is theta 2 with x-axis. For any general
the second
direction,
one will be F2 cos theta 2.
second one is F2 cos theta 2. Foot of the perpendicular from this point, foot of the perpendicular from this point. So this length is F2 cos theta 2. And when you join
the point you are locating is R, not F2.
R cos theta.
Sir, shifting the vector
R
is
cos
parallel
theta
to
2.
F2. They are equal now.
Sir, I shifted
Sir
the
is shifting the F2
to the
vector.
dotted line and then projection on the
we have shifted this vector from this location to this location.
Okay, okay, sir. Okay, sir.
This is equivalent to F2.
Okay,
Okay.
sir.
Yes, sir. Got it.
Okay, sir.
So this is the starting point of F2. This is finishing point of F2.
Yes, sir.
Yeah.
Yes, sir.
Okay. So
Okay, sir.
projection of F2 on x-axis, it is F2 cos theta 2. When you add these two,
Yes.
summation of the projection,
F1 cos theta 1
R
F2
cos
cos theta 2.
theta.
that is
F1 cos theta
corresponding
1
to this
plus
line,
F2.
this point to foot of the perpendicular from this terminal of the resultant R. So ultimately
R cos theta.
R cos theta.
R cos theta.
R cos theta.
And
Yes, sir.
in some abbreviated algebraic notation, it is capital R with subscript small x, Rx. Rx is x component of the resultant R, and that is equal to F1x plus F2x. Okay, so fx for 1, fx for force 2, fx for force F3, etc. All such things, when you add all these things, we get the x component of resultant R along this direction. And when you do the other thing, that is for y direction, so foot of the perpendicular from this terminal, this length is f1 sine theta 1. Then similarly, from this point, the starting point of f2 and finishing point of f2, when we consider that this line represents the free vector for corresponding to f2, so then f1 sine theta 1 plus f2 sine theta 2, that is equal to r sine theta. So in that way, instead of two forces, if there are many number of forces, so there it will be f1 cos theta 1 plus f2 cos theta 2 plus f3 cos theta 3, etc. up to fn cos theta n. When you add it algebraically, then it will be simply the x component of the resultant. Now resolve the force in x direction and in y direction in that way of projection, and you square them, add them, get the square root, you'll get the magnitude of the resultant. So instead of this r directly, if we find this horizontal projection for the right angle triangle and this vertical projection for the right angle triangle, then rx square plus ry square, that is equal to
R square.
r square. So square these two components, add them, get the square root of that summation, you get the magnitude. Now what about this angle theta? It will be y projection divided by x projection. So ry divided by rx, tan inverse of that, or tan theta is equal to ry divided by rx. So I am not going for all such detailed written notes. I hope you can very easily remember all these things. And
Yes, sir.
so if there is at all any trouble, I'll repeat, no problem. But please try to visualize these things. Okay, so either from this forward direction, taking f2 second, or for the other way, f2 first, then free vector f1, same thing will come. Now, if by any chance force f3 is also there, then the line joining the first point of the first vector to the last point of the last vector, this is the resultant
Vector.
Now f1 its component along x, f2 its component along x, these are positive. But what about the component of f3 along x direction?
It's negative.
It is negative. So that's why it is algebraic summation.
Negative.
And when theta is measured from the positive x axis, then automatically that cosine value will come negative. We don't need to consider the separate negative sign for this. So f1 cos theta 1 plus f2 cos theta 2 plus f3 cos theta 3, etc. will automatically give you that algebraic summation, which is the x component of the resultant. Clear? Now, yes.
Sir, what is the angle theta 3?
Theta 3. Theta 3, all these angles are measured from positive x direction anti-clockwise, as you have done in your schools. So it comes in second quadrant. All sine tan cos, cosine is negative automatically. Suppose this angle is 45 degree, so actual theta 3 will be 90 plus 45, 135. So cosine 135 is minus
1 by root 2.
Okay, and suppose some force F4 is there, which is dropping directly vertical downward in this way. So what about the angle there? It is 270 degree. And what about cosine 270 degree? It is 0.
0.
So all such things, when these forces are given in detail, we can make that table. So find sigma fi, the sigma fxi, that means fx for I equal to 1, fx for I is equal to 2, etc. Then algebraic summation of y components of all forces, summation fyi, that sigma fyi, fy for I1, fy for I2, etc. And get these two algebraic summations separately, square them, add them, get the square root, you will get the magnitude of this. And what about the angle? It will be simply tan inverse of summation Fyi divided by summation Fxi. Now you can remember that your school days problem here, where it was, suppose it is like this. Some kind of this thing or other. In most of the books, you have used the notation, the force P, and this is force Q. Then what about the horizontal component of F1 if it is directly horizontal along x-axis? It is simply F1.
Whole. Yes, sir.
F1 plus F2 cosine alpha, because this angle is directly alpha, angle included between the forces F1 and F2. So F1 plus F2 cos alpha is the x component summation.
R cos alpha.
Not r cos alpha, r cos theta.
R cos theta.
Then what about y component? For F1 y component is 0. Only F2 part remains. So it is F2 sine alpha. So now you can remember that crispy formula, whatever you have used, understanding or without understanding, that is tan theta is equal to F2 sine alpha divided by F1 plus F2 cos alpha. Right. And when you square the x component F1 plus F2 cos alpha whole square plus F2 sine alpha whole square, then it comes F1 cos square alpha, F2 cos square alpha plus F2 sine square alpha, or F2 square cos square alpha, F2 square sine square alpha. There is a square, sine square plus cos square, that is equal to 1. So F1 plus F2 square, F1 square plus F2 square, plus F1 multiplied by F2 twice F1 F2 cosine alpha. So how those formula comes naturally you did in detail in your class, but same thing we will not follow here directly. That means adding one after other. So apply the formula for F1 and F2, then find F1 to which is direction magnitude, then combine these two, not in that way. From the very beginning, we'll find individual x components, individual y components, get all individual x components, their algebraic summation, get algebraic summation of all individual y components, and once we get these two quantities, square them, add them, get the square root, that is the magnitude of the resultant. Divide algebraic summation of y components with algebraic summation of x components, we get tan theta. So direction of the resultant with positive x-axis, that is horizontal towards right. Okay. Now suppose there is a force F4, where F4, when you draw here or represent graphically, it starts from this end of F3, and by any chance it is coming to overlap on the starting point of F1.
Sir, muted.
Sir, you are muted. You are muted. Sir, you are muted.
Now?
Yes, sir. Now we can hear you.
Okay. So for this case, just hold a minute. So for this case, when we have a fourth force where the starting point of the fourth force is the finishing point of the third force, and finishing point of the fourth force overlaps with the first point of the first force, then what about the gap between first point?
Resultant.
So there is no gap. So
Sir,
the line
factor
the
basically.
line filling that gap is the resultant in this forward direction, and line not filling this gap, there is a fourth force which is joining to the original starting point of the first vector. So in that case, there is no gap. When F1, F2, F3, F4, all four free vectors are joined one after other, and in that case, it is equilibrium. There is no resultant.
0.
Now, that is one criteria for equilibrium. Other criteria is also there. Not one criteria, it's a criterion, grammatically to be precise. Anyway, so that is the primary condition, or whatever you say, that there should not be any gap between the starting point, first point of the first vector to the last point of the last vector. Then resultant force is equal to 0. That is primary condition for equilibrium. Now, do you get a diagram?
Yes, sir.
Yes, sir.
Yes, sir.
One, just hold a minute. So it's a simple case that one block of mass 1600 kg is hanging, and it is supported by. Now, can you hear me?
Yes, sir. We
Yes,
can.
sir.
It is supported. It may be metallic rods, or they may be two weightless, almost weightless threads, very fine threads, which can hold the 1600 kg mass, and it is the connection point is C, BC and AC. These are two strings or ropes or metal rods, etc. And this geometry is given in this way only by these distances. The angle θ1, angle θ2, all these things are not given. So from this vertical line passing through this point C towards right 400 millimeter distance, there is a point B, the support B. From ceiling, some hook is there fitted, and towards left at 1100 millimeter, there is a hook hanging from the ceiling, and two ropes are fitted there, AC and BC. At point C, one block is hanging with its self weight, or its mass 1600 kg. And how vertically it is located? It is at this distance of 960 millimeter from this level. Okay, a very simple situation. Now, as this block is not moving, it is not falling down, so it is under equilibrium. Now that equilibrium under how many forces? One action force, other two are the reaction forces, which are in the form of some pulling force along this direction for this rope CB, and for that pulling force at the point C, suppose two persons are holding this block, one is pulling in this direction, other is pulling in this direction. So their resultant force is acting vertical upward, which is matching with the weight corresponding to 1600 kg. Clear?
Yes, sir.
Yes, sir.
Now
Yes, sir.
we move back to this situation. Instead of this force R as resultant, if we consider it is the third force, F1, F2 and F3. F1, F2 and one F3 is there, whose direction is opposite to this line, this R, magnitude is same. So in that case, if we want to find out that condition of equilibrium, when F1 and F2 are given, what is the third force for which the system will be under equilibrium, then the force corresponding to this line, normally it is called equilibrant. In the straightforward case, it is resultant. For equilibrium case, when resultant force is 0, then this third force, normally it is called equilibrant, that is required to bring the system in equilibrium when two forces are acting, given by F1 and F2. Okay. Now, just 1 second. I'll finish this very important job. What is that?
Attendance.
Attendance, exactly. But earlier attendance was very important thing in some other way. there are some percentage of attendance 75, below which you will be punished. Some grade may be reduced. Some cutoff might be there at 60% of attendance. For that, you may be declared failed in that subject. So many rigid things were imposed. But now for this pandemic situation, at least we can avail this. Now, sometime if I am attending any class, I will simply make it on and availing some mental vacation, enjoying here and there. But somehow, if teacher asks something, some question for me, I'll be definitely in some trouble. Anyway, please don't mind for this lighter things. Then for this equilibrium. Now for the equilibrium, two things are required. One thing, rather for any force that you know, the magnitude, direction, and its position. Now position is confirmed here. If it is a concurrent force system, naturally that is the point through which that equilibrium will be acting. What about the other two things? Its direction and its magnitude. Now we consider a very basic mathematics or that geometry. Sorry, here. That we are talking about a triangle, how we draw a triangle, how in different way we can draw a triangle. Either the very first situation, three lengths of the three sides are given, then draw the first line from its terminal, draw two circular arcs. One radius will be this length, other radius will be this length. Draw these two arcs, get the point of intersection, then join this point of intersection of these two arcs with the terminal points of the first line. That's all. Next thing, suppose this line is given and this line is given, the length. Suppose this is 70 millimeter and this is 50 millimeter. Now can you draw a triangle? There will be infinite solution. 70 millimeter you take with its rigid position. Then if we draw a circular arc of this length f2 about this center, then from any point on the circumference of that circle, you draw a line connecting any point on the circumference with this terminal point here. There may be infinite solution, but how to get one unique solution or one particular? We need this angle.
Yes, sir. Angle.
Okay, so side A plus side B plus angle C, or three angles are given. Suppose 60, 60, 60. It is equilateral triangle, but you can draw infinite number of triangles. 5 millimeter, 5 millimeter, 5 millimeter, 25, 25, 25. So all these 60, 60, 60, there may be infinite solution. So equilateral triangle with the length of one side, it will be given. Other given data might be like this. Two angles and one side. Suppose this is the side given. We draw a line which is given length. Then at this end, draw a line passing through this point. Extend it. We do not know where it will terminate. From this point, draw another line with that given direction, and we draw this extended line. Get this point of intersection. This will be the vertex of that triangle opposite to this side base. So either two sides, one angle, or one side, two angles, or three sides in length. But all three angles will give you infinite solution. So here also, when we go for that solution for this triangle, we need such kind of thing. So how many information are there? Side A, side B, side C, angle capital A, angle capital B, angle capital C. So out of all these things, you can solve at most two unknowns. Now, how it is that? Because now you compare from that equation you have developed. The horizontal component of R is summation fxi. vertical component of R is summation FYI. So to know R completely, you have to solve these two. For equilibrium, summation Fxi is equal to 0.
0.
For equilibrium, summation FYI, that is equal to
Net.
0.
again 0.
0.
So these two independent equations you need to solve to find out the resultant. So F1 cos theta 1 plus F2 cos theta 2 plus R cos theta, that is equal to 0. Then F1 sin theta 1 plus F2 sin theta 2 plus R sin theta, that is equal to 0. Solve these two. You solve two unknowns R and theta. So that is the way we think. For solving these two equations, it may be of different formation. Either two sides are unknown. That means resultant is given and angles are given. So you need to find out the original given forces, or not given magnitudes, F1 and F2. So it may be of different combination. But ultimately, the diagram will be a closed polygon. For this case, it is triangle. So first line, second line and third line for equilibrium, it is a closed triangle, and the basic geometrical rules you have to satisfy. Then we can extend all these things for more than two number of forces for equilibrium of three forces, etc. Now a special thing regarding three forces. Now we go back to this situation. You forget about this R. F1 and F2, two coplanar forces passing through this point. What is the equilibrium force? Opposite to this, something like minus R. Now, if it happens in this form, two forces F1 and F2, they are not given as concurrent, but we can extend these two lines of action to get some point of intersection. Anyway, we forget about this. Just those are acting through B and C. F1 and F2 are acting. Now, what about the resultant? It is R. What about theta? That we can find. What about the position? That we do not know. How to know it geometrically? Extend these two lines, get the point of intersection through this point. Here is a fixed position. That through this point, draw a line with that determined angle theta, and magnitude along this direction will be the magnitude of that resultant force R. Now, instead of R, if we have a third force of magnitude R, rather minus R, direction opposite to this plus R, then what about the condition of equilibrium? The first geometrical criteria is that the third force must pass through this point opposite to the direction of the resultant determined along this line, but in this direction. But along this line means it is here. So the very important condition for equilibrium for three coplanar forces is that the three forces must be concurrent. Then only we can think of the criteria of equilibrium. So first of all, they must be concurrent. So if different locations are given B and C, extend these two lines of action. So through this point, the third force will act. Sometimes we call it the equilibrium, not this resultant, opposite to that. So we must remember that condition of equilibrium for three forces in a plane is that they must be concurrent. After that, algebraic summation of all forces along each direction, that is 0. Separately, algebraic summation of component of all forces along y direction, that is also 0. And now you solve it. Sigma fxi is equal to 0, sigma fyi is equal to 0. And as you know, you can solve maximum two number of unknowns from these two independent equation. There may be combination of any two unknowns. Which are any two unknowns? Either for this triangle, either two sides or two angles or one side and one angle. So primary thing is very simple. It's very easy. But when you are appearing for exam, then in your question, it may be of any formation of unknowns. That is, either you determine the equilibrium completely with its direction, magnitude, position, or you find one magnitude, one direction, or two unknown directions. Find these two directions so that equilibrium is possible in that way. Or for the given directions, find the magnitudes of the forces to be applied to arrive to that equilibrium condition, whatever it may be. So you know all such tricks because you have gone through those hurdles and you crossed that big target set to join on NIT. I once again congratulate you for your performance. I wish every success in your life, and I don't know whether you have been shared or not. Recently, in newspaper, there is a big news for NIT. So for campus interview or recruitment from campus, Microsoft had selected few people and they are given the package of 47 INR lakhs.
Sir, domestic or international?
That much I do not know.
Sir, in that
Domestic.
25 is joining bonus.
मुझे न्यूज़पेपर से ये मिला और उसके पहले डायरेक्टर सर भी शेयर किए थे हमारे एक व्हाट्सएप ग्रुप है
46.
I can send you that. So let us go back to that condition of equilibrium where you are discussing about this problem. Now when it is of this kind of simple situation of equilibrium where these angles are not given, then you need to find out these forces developed in these two members, the supporting forces or holding forces, the angle with the horizontal. Now what about this angle or what about this angle? You can find in terms of tan theta. If it is theta, tan theta will be 960 millimeter divided by 400 millimeter. If this angle is theta 2, not in that formal sense of angle theta 2 here measured with the positive direction of x horizontal towards right. If we consider the simple geometry, this angle is theta 2. In that case, it will be tan theta 2 is equal to 960 divided by 1100.
0.87.
Okay, we'll check it later. But before that, this part is very important. We consider the knot C or joint C. Now on this knot, how many forces are acting? The first of all, the self weight of that block 1600 kg multiplied by 9.81, we get this many newtons. Now some force is developed along this member CB, some force developed along this member CA to hold this weight 1600 multiplied by 9.81 Newton in its position. Okay, this is Newton. Here also this will be Newton. Then theta 1 is given by tan theta 1 is equal to 960 divided by 400. Tan theta 2 is 960 divided by 1100. In that way. After that, for equilibrium, these three forces can form a triangle. Now what should be the known side given in all respect? Direction is vertical downward for this given weight. Length is proportional to 1600 multiplied by 9.81. Now one thing I should mention, that is normally from our schools, to avoid those calculations complexity, we assume G value as 10 meter per second square. But here,
sir, how
here
to calculate exact value of theta? 10.
Here you need to consider it as 9.81 or whatever it may be, 9.807 or whatever it may be, it is given there. And other things, these directions are known. The forces developed in these two supporting ropes are to be determined. So solve sigma fx0, sigma fy0 to find out these two unknown forces. So tan theta 1 is this 960 by 400, tan theta 2 is this, then sigma fx is equal to 0 gives us SCB cosine theta 1, then SCA cosine theta 2 in opposite direction, it is negative. And what about the contribution from this weight? For vertical weight, there is no, this is 0.
Sin theta 1 equal to
So the
the
sign
downward.
components will balance the
Both forces, sign versus is used
sign
to
component of the
equilibrium.
Please be clear, and only one voice should come, otherwise it is overlapping and making clumsy.
Sir, I'm saying that the sign components of the two forces will balance the downward force.
Later. First of all, horizontal components. There is no contribution of this hanging weight in horizontal direction. Only two forces are contributing in horizontal direction, SCB with cosine theta 1, SCA with cosine theta 2 with negative component, and that is equal to 0. That algebraic summation is equal to 0. For vertical component, SCB sin theta 1 plus SCA sin theta 2 minus 1600 multiplied by 9.81, that is equal to 0. So you are talking about this SCB sin theta 1 plus SCA sin theta 2, that equals to this, but I am expressing it in the form of this equation of equilibrium. So
Sir,
either
can you make it faster? Actually, other classes there from 11th, sir. From 11th.
Okay, so so do you get my point that you need to solve these two to find out the unknown forces developed in the rope in member CA and member C? So that's all. That is very simple. You solve it. So definitely we'll close our session. So please permit me.
Thank you, sir.
Okay, sir. Thank you.